So for today, it's a review to see if you are up to date. And I'm going to actually start this one, not with the one that they start with, but I want to go back to those specials. By now, you should know the special right triangles. So imagine for a moment you had a 30, 60, 90. Would you please write the sides on that? So draw out your special and then write out the sides on it. This is the part where cell phones go away. And I need your full attention. And then a 45, 45, 90. And write the sides on there. Then let's see if you learned how to use those sides. If I give you this side is the square root of 17, then I'd like you to tell me how long h is. And if this 45, 45, 90 triangle had a side length of square root of 3, then how long would, let's say that, let's call this B. No, that's too easy. Got to do the hypotenuse. H. Okay. In a moment, I'm going to have you compare with the kid sitting next to you. Let's get into game mode. Act like this is a test. You are supposed to know how to do this at this point. Okay, let's see how you guys did. The side ratios, it should be 1, 2, and the square root of 3. I strongly recommend that you always start with a 1 on the shortest side, and then you go to the longest side and put a 2, and the other one is the square root of 3. That makes it easy as 1, 2, 3. Any questions about how that works? Okay, next, 1, 1, and the square root of 2 are those side ratios. Then, this one, you'd go, always start with the variable. H is to 2, like root 17 is to root 3, multiply both sides by 2. And I'm going to put the 2 in front just to make it nice and clean. 2 root 17 over root 3. Raise your hand if you had that one right. Awesome. Okay, the bottom one. H is to root 2, like root 3 is to 1, but that's just root 3. I'm going to multiply both sides by root 2. Root 2. If you were extra smart and said root 6, I'm impressed. H is root 6. Any questions about that one? Yes?
In the first problem, do you have to multiply both sides by the square root of 3 over the square root of 3?
Nope, because remember, we talked about this. Minnetonka does not require you to rationalize the denominator, but you can. Okay, so that, just to clarify, that makes that square root of 9, which is 3. That way there's no square root in the denominator, so that's not required. All right, moving on to, if you have a just a normal trig problem. I want to make sure you can solve a normal trig problem. Let's say this is 20 degrees, not a 30, 60, 90. Let's say that this is x, and let's say that this is 7. With a calculator allowed, I'd like you to start by writing an equation for that, like sine. Why did I choose sine? Because I have an opposite and a hypotenuse. Okay, sine of the angle equals, and then hopefully you can figure out sine of 20 on your calculator, and you can solve this equation for x. In the end, I want to know what x equals. You talk to your partner about what equation you should write and how to solve it. Pausing for a second. Okay, did you know it was supposed to be sine of 20 equals opposite over hypotenuse, x over 7. I don't know what sine of 20 is, but I'm going to solve this exactly. See, if you used a calculator, that's cool, good, but I'm going to times it by 7 on both sides and watch what happens. I got my answer. Faster than you, and it's more accurate. Because sine of 20, by writing that, you've got a decimal that'll go on forever and never repeats. Whereas if you use your calculator, you're going to have to round that off. Do you get what I'm saying? So this is the exact answer. Some people think calculators are exact. They are not. Calculators only can give you an estimate because you have to stop their decimal. Okay? So if you did use the calculator, though, and do sine of 20 times 7, raise your hand if you've got that. Somebody just help out. Tyler, what'd you get?
I got 7 sine of 20.
One more time.
7 sine of 20.
Yes, 7 sine of 20. Multiply that out, and you got some decimal, right?
Yeah.
What is it?
2.394.
2.394. Thank you. 2.394. Can anybody verify that that's what they had as well? Okay. All right. Let's make sure you got that because not many people seem to have understood that. Either that or you're not raising your hand. When I say if you got that right, raise your hand. You know, we're going to just keep doing it until I feel like everybody's got it. All right. So if you just decide to say, well, I'm not raising my hand, it's too taxing. Then we're going to keep practicing. All right. Let's say this is a 4. And this I don't know. You can figure that out with sine, cosine, or tangent of 20. Solve for the question mark. If I were you, I'd make it a letter like A, B, or C, and C wouldn't be logical. So make it an A or a B. Okay, I'm pausing for a second while you try that. Oh, and just to clarify, this is a right angle. Otherwise, you couldn't do it. Not even with the law of sines. But now that you know that that's a right angle, you have 3 pieces of info, which is what you always need. If you have 3 pieces of info in one of your triangles, you're going to be able to figure out everything. Okay, let's see how you did. I would have used tangent. How did I pick that? Because I had TOA, opposite one and adjacent one. So tangent of 20 is 4 over, I used B. All right, then I'm going to multiply both sides by B, which may seem slow, and it kind of is, but it clears the fraction at least. Then I'm going to divide both sides by tangent of 20. And I get B equals 4 over tan 20. That is an accurate answer because I haven't messed it up by a rounded decimal. But I hope you actually did type it in with a rounded decimal. And you get 4 over, what was the tangent of 20? Say it if you know it. 10 point what?
99.
Thank you. And then 4 divided by that. What did you get for a final answer? Raise your hand if you have the decimal for that. Okay, what is tangent of 20? I guess I should get a calculator out. Tyler?
0.364.
364. And then when you divided 4 divided by 0.364, did you get 10.99? All right. And that probably means if you factor in rounding and stuff, that really would be 11. Raise your hand if you had about 10.99. Okay, good. I think you're getting this. Then, law of sines. Imagine for a moment you have a big, wide open triangle. Is this a good setup for law of sines? Well, depends. If this is 100 degrees, and this side is 8, and this side is 7, this is not a good setup for the law of sines. Why? Yes?
It doesn't add up to 180.
True, we don't have the angles adding up to 180, but they could. The angles could still add up to 180, but why doesn't the law of sines work well on this? Tyler?
Because it's a sandwich.
Yes, this sandwich kind works for the law of cosines. If I knew an angle on the side across from it, a lot of you didn't know this, I can tell by how few hands went up. If I know this, then it's a good setup for law of sines. You want an angle on the side across from it. Okay? Then it would be a good setup. All right, now not every number works. I'm gonna try to think of what number I can be confident will work. This is called the ambiguous case, which is something we're talking about today. But can you tell by how, if I made this side be 3, can you just look at it and see that there's no way that side could be 3? and have a 100-degree angle there. Do you get what I mean? So there are some numbers that just can't work. And that's what we're talking about today mostly. So I'm going to try to make this one work, though. I'm thinking... I think if I made it... Who's got a good guess? I'm going to let you guys take a shot at this. How long do you think that side would be? If the other one's 7, definitely looks way longer than 7. Do you think it's as long as 14? Do you think it's like 13, 12? I mean, what's your gut? What's your gut? We just have to keep it proportional, you know. If this is considered 7... Jacob, what do you say?
Maybe around 13, 14.
All right, let's make it 13. Assume for a moment that's 13. And then if you guys get the answer and the answer is no solution, we'll know, we'll call this B here. We'll know that something got messed up. Like that, maybe that side of 13 just isn't possible. That's really common on this type of a question. All right, so solve for B using the law of sines. Sine of big A, or little a, the first thing I would have done is labeled my A's, B's, and C's. Okay? And I don't know if you remember this, but the key angle that you have, we should call that C. And it's usually the biggest angle. And that's not always the case. So this isn't a must on the law of sines. But when you use the law of cosines, the angle that you're using in the law of cosines has to be C. Okay, so C's always been the special one. Of A and B and C, C's always been the hypotenuse in a right triangle. So make C the angle you're focused on. All right, so that's going to be C, and that makes this little c. And then the A and the B, we really don't care. Just like on the law, you know, A squared plus B squared equals C squared, we didn't really care which one was A and which one was B. All right, so since I said this was little b, this must be big B, and then this last one can be A, and this must be little a. All right, once you get your letters straight, then it's just plugging it into the formula and chugging through it. I'm going to pause for a second. Let me give that a try. Sine of 100 over what? 13 equals, and what did you do? Did you use the B or the C? Oh, you used the A. Okay. All right. Then yes. So I really put that here, so I kind of like put it under the wrong thing. But I'll go over here and put in sine A. What is A? We don't know. So I say sine of A over 7. And look, I have 3 out of the 4 parts. It always comes down to 3. If you have 3 things, you can solve for everything else. Okay, so now I'm going to multiply both sides by 7. Why did I do that? Because it clears the fraction out. And now sine of A is alone. And that's just a number. It's an icky number, but it's a number. And then I do inverse sine of that number to get the variable alone. I'm going to use a different color here to make that more clear. Inverse sine on both sides. And inverse sine cancels sine, and A is alone. It's the inverse sine of all that. Okay? So, Catherine, what did you get for an answer?
I got 32 degrees.
All right. Raise your hand if you got about 32. Nice. So if that's 32, that's 32. Do you get I instantly know angle B? Because 132 and that other angle have to add up to 180. This is a key thing that people forget. These 3 will add up to 180. So then it's got to be 40 something. What did you guys say? 48. So if that's 48 degrees, then I have to do this law of sines one last time to figure out B. So then I'm going to go sine of 48 over little b is equal to, let me think, well, it doesn't matter. I can do either one. But we technically rounded b, so I'm going to use a. Sine of 32 over 7. And once again, timesing both sides by b. No, wait, I'm wrong on that one. We don't want to times both sides by b. We want to times, we want to get, oh wait, I do want to get b alone. So yes, I want to times both sides by b. But now, this is a pain. I'm going to have to get that off of there. So I'm going to multiply both sides by 7 next. Times 7, and the 7 goes away. And then I divide both sides by the sine of 32. So my final answer is b is equal to 7 sine of 48 over sine of 32. Is that accurate? Yes, it's extremely accurate. But, Goldsmith, what did you get for the final decimal?
9.8.
Anybody verify 9.8? A lot of people. All right, cool. If not, then you should try typing this in and see if you made a mistake in the typing it in or something. All right. So that's law of sines. What's the last law? What's the last law? Law of what? Yep. Law of cosines. Okay. And some of you are going to have a really good memory from yesterday on what the law of cosines is. It starts with a squared plus b squared. Who remembers that little extra piece? 2 people? Come on. 3 people maybe. 4 people? Oscar, give it a shot.
Is it minus 2ab equals c squared?
Oh, you're so close. Remember, it's the law of cosines.
Oh, cosine.
There it is equal to c squared. That's the law of cosines. And you'll recognize a squared plus b squared equals c squared, right? So it's just got this extra little factor in here. This is used for not right triangles. Because if it was a right triangle, it'd just be a squared plus b squared equals c squared, right? Okay. Now, I'm just keep reminding you of that formula. Technically, tomorrow is the day that you do law of cosines. Today, what the heck are we doing today then? We're going to just basically do more complicated looking law of sines problems. Okay? So I think by now, I hope, you're feeling okay about this review that we just did. And now it's kind of like, now we just have to do problems where the numbers look more complicated. This one's not that much more complicated. In fact, it's not the ambiguous case I keep leading up to. But would you please try this one and figure out the 2 angles that are unknown. This angle and that angle. First thing I'd do, I'd go in and put in some letters. And be the same as your partner, please. Decide what you want to call A, B, and C.
So that's the red is A, and the B, and then white is B and C.
Okay, I'm hearing some debate about which should be which, and you guys can do anything you want. Because we're not using the law of cosines, it doesn't really matter. But if we had been using the law of cosines, the key angle had to be C. We're not using law of cosines, so you don't have to, but just for future reference, trying to remind you of that because that's a really common mistake for kids. That should be C if you're using the law of cosines. Okay? But in this case, it doesn't matter because the law of sines is easier. On this one, why don't you just work separately and then wait till the end and see if you get the same answer. Unless you just need help, in which case, go ahead, lean over and ask. But okay, again, my letters might be different than your letters, but I bet you all had sine of 40 over 20. And I chose to call the other one B, the red ones, the red question marks. And so if I am trying to get the b alone, I'm going to times by 15 on both sides. And now I have, this is my big nasty number, and I do inverse sine of that. So help me out. I'm going to use Dice of Destiny to call out somebody so you don't feel like I'm picking on you all the time. This is row 4, last person. 1, 2, 3, 4. Last person, that's you, sir. Mr. M. Raise your hand if you had 28. All right, about 28, if it's rounded. Okay, all right. So if you didn't, then I would retry typing in 15 times sine of 40, enter, and then divide by 20. It's really common for people to script the order of operations there. I would get this into the calculator first, hit enter, then divide it by 20, hit enter, and then do inverse sine of that. Is anybody concerned that that's a wrong answer? I'm just hearing a little bit of chatting and stuff.
I got 28.8.
Anybody else have a high 28, like 28 point? Okay, then that's probably a rounding thing. Like seriously, if you round to 1 decimal place and somebody else rounds to 3, the answer could be quite different. Okay, so it's all about how far you rounded. Who wins in a battle of rounding? Whoever's more accurate. So, moral of the story, use as many decimal places as you can. Because a lot of times in these tests, I'll give a range. Like, okay, I understand if the kid rounded 3 decimal places, they'll probably get this. And the kid who rounds to like 1 decimal place, a lot of times is too far outside the range. Okay, so give yourself more accuracy by having more decimal places. Okay, so actually it's high 38s, like 38.8-ish. All right, let's move on. This one, if you solve it, I'll just save you the time. If you solve that, it'll say no solution. And something will be messed up. All right, so I think we should actually do it, and I think you should solve for this angle right here. And let's follow that rule I've said where the key angle I give you is C, even though we don't have to do that because we're doing law of sines. But then let's call this one B, and let's call this one A. We'll all use the same letters here. Okay, so label that with A, B, and C. And now I would like you to solve for B, and I want you to see why it's messed up. Because you're going to get an answer. But it's clearly a wrong answer when you look at the diagram. So I've told you before to watch out because sometimes you will get an answer of no solution. Well, this time you get an answer. But it doesn't work. Okay, so I thought this was a different question. I apologize. I thought we were going to get an answer, but it'd be the wrong answer. It's my bad. This one is just one where you can't have an answer. All right, here's why. If you actually looked at this situation, this 8 length would not be able to connect. It wouldn't be long enough to connect that side. 8 isn't big enough. If you actually had this side dangle free, it would fall short of even making a right triangle. So this is too small. All right, so this is the beginning of what's called the ambiguous case problem. So you can't draw the triangle that way. It just won't work. But what if I made that side a little longer? What if I made that side long enough so it could touch, but it could touch in 2 different directions? Like, let me show you what I mean. Let's say that I made it long enough so it could go this way, or it could go this way. Well, first off, I want to act like this was a right triangle. This blue side here, I want to see how long the blue side would have been. If you're smart about this, you'd be able to figure out what this side is, this blue side, if it's a right triangle. And hint, it's longer than 8. So act for a moment like this doesn't even exist, and you're just trying to figure out how long the blue side is. Everybody do that. We just practiced that a minute ago with Trig. Find the blue side. If we made it a right triangle, what would the blue side be? I'm going to change because I can tell some people are kind of baffled here. This is 12. This is 60. This is a right triangle now. So we do have 3 pieces of info. 2 of the angles and 1 of the sides. That means I can figure out everything. So the question is, how long's that side? All right, have you figured it out yet? How many people have got the answer for how long that side is? All right, good. So let's go with Isaac. What do you say?
It's like,
Approximate is okay.
I got sin 60 times 12.
Oh, and I need an actual decimal. Somebody got the actual decimal? Jacob.
10.392.
10.392. So about 10.4-ish. Yes?
Since it's like a 30-60-90 triangle, wouldn't it just be like 6?
It depends on, nope, you're thinking that that's the smallest side. We have to trust that this is actually the 60-degree angle, which makes this the 30-degree angle, which means this side would be 6. All right. All right, so back to, it's about 10.4. Do you see why 8 couldn't have worked? If this side was 10.4, then there's no way 8 could have connected over there. It wasn't nearly long enough. But if I made that 8 be not an 8, if I made it be an 11, everybody change the 8 to an 11. And then something else weird happens called the ambiguous case. Ambiguous means you're not sure. It's not clear. It'd be kind of like, hey Jack, we're having a party on Friday night. Did I just ask Jack to go to the party? It's not really clear. It was kind of ambiguous. Couldn't tell. Maybe I'm just telling him that I'm having a party. All right, so the 11 is ambiguous, and I want you to figure out why. Figure out this angle right here. And something weird's going to happen. All right, Tadros, what did you get for that angle?
Not fully done yet.
Okay. Give me more time. I'm going to do sine of 60 over 11 is equal to sine of b over 12. Now I multiplied both sides by 12, and I divided that all out, and I got 0.945. Did anybody else get like 0.944 or 945? Okay, good. And then you do inverse sine of that. And how many of you know what second answer is on the calculator? Only 3 people know what second answer is. This is going to save you so much time. Figure this out. Ready? I want you to clear out your calculator completely. Everybody get it cleared so that you have a nice blank screen on your screen. Okay? Ready? Now put your calculator next to, on the side of your desk so the other person can see it, because a lot of people are going to get confused by this, and I want you to have a helper. Okay? Everybody put in 0.94475, 0.94475, and hit enter. Now that's the most recent thing in the calculator's brain, right? Now if I want to do inverse sine of that, everybody do inverse sine, and just stop after you do inverse sine. Now some of you are doing is typing out 0.94475, and it's a pain in the butt. So watch what you can do. The second key, and then the answer key, which is right above the negative key. And it brings back the previous answer. Again, A and S, it's above the negative key on the calculator. It's above this key down here. It's on the bottom row. Second answer. And that brings back the most recent entry in the calculator. That way, you won't have to retype out some long answer. Sometimes they're really long. And this also helps because you don't have to round it. See what I mean? You can have this super long, accurate answer and just bring it back down and do inverse sine of that. Okay, cool. And did you get about 70 point, I'm going to round it 70.9 degrees? All right. Now I'd like you to look at this. 70.9 degrees. There is another angle that would have worked for the 11. And that's if I'd have drawn the 11 like this. Do you get what I mean? The 11 could have gone swung out, or it could have swung in. These could both have been 11. So 70.9 is one of the two triangles that this thing could form. The other one is this black triangle here. And then you don't have to do any long calculations. You can just think. If this one would have been 70.9, then do you get that this one in this corner right here would have also been 70.9? Think about that. It's an isosceles triangle. This side's 11 and this side's 11. So the angles across from them have to be the same. That could be 70.9 and that can be 70.9. And then that tells me what this angle would have to be. So I take 180 minus that, and notice I'm going to use second answer. Everybody do that. Type 180 minus second answer. That way I don't have to round it, see? Do you get 109.133927? That's how you keep a really accurate answer right to the end. Now, do you expect that I'm going to ask you to write out all your decimals? No, you're not really that accurate anyways. But now you've been super accurate as far as you can go, and now you can round it and say that's about 109.1 degrees. That's the ambiguous case. Why is it ambiguous? Because you can't tell whether this 11 would be swung this way or swung that way. All right, let's do one more like this so that I can feel like you really understand this. So we're going to make an angle this time of 45 degrees. We're going to say that this side is 10. Would you agree that a side length of 1, there's no way it would connect? If this side was a length of 1, do you get how that could not connect? They couldn't make a triangle then. See what I mean? Yep. So how long is the minimum length that this could be? Everybody figure that out. That would make a right triangle. If it's a right triangle, you have three things. You have a 90, a 45, and the length of 10. You can figure out this red side. I'm going to use sine of 45 is equal to question mark over 10 times both sides by 10. 10 sine 45. Go to my calculator. 10 times did you get about 7? Okay. So that is not ambiguous. That would be exactly how long it would be. I'm going to round it to 7.1. That's how long it would be if it was a right triangle. So then what side length would make it ambiguous? Something over 7. Like maybe 8. So I'm going to say, what if the side was 8? Can you see that it would have to swing either this way or that way? Either way, it could be 8. I'd like you to figure out what these angles are then. This will be the same as this. I'm going to erase out this right triangle because it's not really right. But these two question marks that are blue would be the same, and then this red question mark would be different. That is the ambiguous case. The 8 length would make it not clear whether you'd swing out or swing in. So sine of 45 over 8 is equal to sine of question mark over 10. And multiply both sides by 10. I'm going to do 10 sine 45. Do you guys know that you don't have to hit the end parentheses? If you haven't figured that out yet, when it says 10 sine 45, if you don't put the end parenthesis in, it'll still work. You just hit enter. Okay? Just trying to save you a little bit of time. You also don't have to say times between the sine and the 10. You just say 10 sine. It knows to do times. All right. And then I divide by 8. And now I have to do inverse sine of that. Second answer brings my long, awesome, not rounded decimal back. Did you get 62.1? All right, now look at it. Do you get that can't be 62.1? Look at it. There's no way that can be 62.1. So which one did you just figure out? This one. That one's got to be 62.1. And that means this one also has to be 62.1. Both of these are 62.1. And the other one must be 180 minus second answer, the 62.111. And I get 117.9. Who else got 117.9? Sweet. I think you get the ambiguous case problem. So that was a review of everything we learned, plus the kind where you have to make a isosceles triangle at the end and see if that side was 8, that it could swing in 2 different directions and find both of the angles. All right. So these are examples of cases where you could make the problems ambiguous. I want to show you how they do the homework. So here's a typical homework question. I kind of don't like it because they don't draw it for you. But, you know, it's okay. It's good for you to get some practice drawing these. So everybody draw yourself a 6-degree angle. Would you agree it's pretty small and you don't have to be incredibly accurate? Okay, and this is big A. Remember me saying that they used alpha for A? All right, and this side across from A is 57. Side B is 100. This one's 100, the top one. And this was 6 degrees. I'm warning you, answers sometimes won't work. Remember how the triangles, sometimes you can't build it that way? Maybe that 57 is too short. And it just can't work. If so, when you look at the key and it says no solution, you can verify, oh, yep, I set it up right, but maybe that 57 is the ambiguous case where it swings in 2 different directions and could be 57. How do you know? You can't know. Well, you can actually if you do a bunch of complicated things. Like if you figured out exactly how long this was and then figured out if 57 is longer than the right triangle, then you'd know it was the ambiguous case right off the bat. But if I were you, I'd just draw it, and then I'd figure out the angle. And if the angle comes up no solution, I'd know there was no solution. If the angle comes up like less than 90, which it will every single time, you are figuring out this angle. And then remember that there's this angle, and the blue one, the blue ones here will always be the same. All right, so when they do this, first thing I want to remind you, I was trying to talk about this yesterday, but you didn't see one, so you probably don't know. That's the lambda, and that's a C. So that's like capital C. Why don't you just write a capital C right over the top of it? Okay, so they say it's 74 degrees. So you make something that's a little less than 90, and you call that 74. 74.6, I guess. And that's C. And side C across from it is 3. And then angle A, or side A, sorry, is 3.05. That's always going to be the top one because, see, the bottom one, it's ambiguous. I can't tell if this 3 is going to swing this way or this way, so I don't know how long this thing is. That's why they don't ever give you the bottom side. So when they give you your A side, that's always the one that's on top. This bottom one could be 2 different lengths. We don't know because it's ambiguous. All right, so that's how to set up your problems. Then, once you set them up, you should solve them and try to figure out what is this angle right here. And you'll know it's the same as that angle right there. Okay, I think you know the drill about homework is really, really important. And I can't make you do it. But if you don't practice this stuff, your next test, you're going to be toast. All right. That's all I got for you for today.